Hello everyone. In this video, I am going to discuss about some problems, and after that, I will be discussing about one and onto of linear transformation, and then I will discuss about similar matrices. So first question you can look at here. First question is given as T is a linear transformation from V to R square. T is a linear transformation V to R square, and T of x, y, z t is given x minus y and z minus t. But here this question is a little bit some tricky question, uh, where V is spanned by 1012, 2134, and 3146. So how you will handle and how you will proceed in such type of problem. So let us assume that if it was not given to you, V is spanned by these three vectors. So in that case, because you are looking here, V is spanned by 1, 0, 1, 2, these three vector, and you are looking, there are four component in each vector. So we can say this linear transformation is from R power 4 to R square. So in that case, we can apply standard basis of R power 4, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. And after getting output, that output we can convert into row echelon form. We can calculate the basis for image t, and similarly, because range, they are also asking calculate kernel t. So for kernel t, you are knowing that kernel t means what? Image says image directly we can put 0, and we can solve the system of linear equation, and solution set of the given system of linear equation is kernel of linear transformation. But this question is uh, somehow different, because here V is spanned by 1012. So basically this question is also easy. So just we can apply given basis 1012, 2134, and after calculating image of this vector, we can convert in row echelon form. So first what you will do, first you can calculate image of T1012. So first I am going to calculate range of T. Range or image of linear transformation, both are same thing. Range of T. So how you will calculate range of T? So for that we have to calculate first T of 1012. First basis is given 1012. So what will be this one? This time, just only you keep in mind, we are not going to calculate image of standard basis of R power 4. We have to apply the given vectors. 1012 will be what? You can calculate 1 minus 1. Similarly, T of second vector is given 2134. 2, 1 and 3, 4. This will be what? 1 minus 1. Third vector is given 3146. So 3146. So what will be image of this? 2 minus 2. So now we can form one matrix A equal to 1 minus 1, 1 minus 1, 2 minus 2. So we can convert this matrix into row echelon form. So basis for range T, this will be what? So you are looking here, these three rows are similar, and by applying row operation, this second row also we can make 0, and third row also we can make 0. So basis for range is what? 1 minus 1. Similarly, now how to calculate kernel of linear transformation? Because the given transformation is what given. And also we can calculate what is dimension, because you are getting only one vector. So dimension is 1 and basis is 1 minus 1. So how to calculate kernel of this linear transformation? So because kernel linear transformation is given T of x, y, z and t. This is it what given? X minus y and z minus t. X minus y and z minus t. So for kernel of linear transformation, we know that image should be 0. So for kernel t, this x minus y and z minus t, this should be what? 0, comma 0. Because 0 in R2 space 0 is what? 0, comma 0. So this will imply first x equal to y and z equal to t. So this x, y, and z and t, this was the random vector of R power 4. This we can write because x equal to y, so we can write x, and y is also x. and we can write z, and t is also equal to z. So now you can take x common, so you will get 1 1 0 0, plus you can take z common, so 0 0 and 1 1. So these two are the basis for kernel of linear transformation. So these two are the basis for kernel T. What you can write? Basis for kernel T. This you can write 1 1 0 0 and 0 0 1 and 1. So what will be dimension? Dimension, because there are two vectors, so dimension is 2 and basis are these things. So if you are not given standard inner product standard basis, so we can apply the given basis. Yeah, next question is given T linear transformation from R square to R square. So and T of x y is given x minus y x plus y. Then we have to check whether T is 1 1 or not 1 1, T is onto or not onto. So for 1 1, you just keep in mind for 1 1 function, if T is 1 1, if and only if this kernel T equal to 0. As we have explained in the previous videos, linear transformation is invertible if kernel T is 0. So if linear transformation is invertible, it means what? Kernel T has to be 0, and same concept, same thing you can apply for 1 1 and onto function. So if T is 1 1 means kernel T equal to 0. So let us assume that, let us calculate what is kernel of this linear transformation. So we know that kernel T means what? Let x comma y, this is a random vector of R2 which is belonging into kernel of T. So this will imply what will be T of xy? So T of xy 0. Because if any random vector belonging in kernel, and if you will apply linear transformation, so image should be 0. This is the definition of kernel of linear transformation. So what you will get? X minus y equal to 0 and x plus y equal to 0. So easily you can solve these two system of linear equations. So you can add y0 and x0. So what we can say? Kernel of t equal to 0. Kernel of t 0 0 means what? The given linear transformation is 1 1. And how you will check onto? Because we can apply rank nullity theorem. What is rank nullity theorem? Rank of t plus kernel of t. This must be equal to what? Dimension of image set. So dimension of R square. So here rank of T is what? Because kernel dimension of kernel T we are getting 0 0. So kernel T is 0. So rank of T we are getting equal to dimension of R square. And for onto we are knowing that what is onto function, we have also studied in intermediate. Onto functions means what? If we are having a function from x to y, so what is meaning of onto? So this f of x, this completely should be what? Y. So dimension of image set, this must be equal to what? Dimension of codomain. So what is dimension of codomain? Dimension of R2 is 2, and dimension of image also we are getting 2. So clearly we can say that this transformation is 1 1 and onto both. So for 1 1 and onto also we need to prove that kernel of T is 0 comma 0. Yeah, next concept I am going to discuss similar matrices. And what is definition of similar matrices? A and B are said to be, this is a indication, this is notation of similar matrices. A and B are similar matrices, if there exists a matrix P and P is non-singular, such that B equal to P inverse into A into P. So this is the definition of similar matrices. So let me discuss some problem. So P inverse AP equal to B. So A and B, these two are said to be similar matrices. If B can be written P inverse AP, and in same time we can write also A, we can also write A equal to P inverse into B into P. So this is also condition of similar matrices. So if two matrices are similar, then this B matrix can be represented in the form of P inverse AP. So if you are having two similar matrices, then what you can claim? We can claim that because if you will apply determinant both side, determinant of B, this must be equal to determinant of P inverse AP, and we know that determinant of A, B, C equal to what? Determinant of A into determinant of B into determinant of C. So we can say because determinant of P and P inverse, it will be cancel out. So finally we can get determinant of B. This must be equal to what? Determinant of A. So now you can apply determinant of B minus lambda I. So if there are two similar matrices, if A and B are similar matrices, then we can say that A and B having same characteristic equation. By characteristic equation, we can calculate eigenvalues. And if characteristic polynomial same, then we can say eigenvalue of A and B are same. And hence we can say trace of A and B are same, but we cannot claim about eigenvector same. So similar matrices having same eigenvalue, same eigenvector, same eigenvalues, trace same, determinant same, but eigenvector may or may not be same. So in general, eigenvector similar matrices don't have same eigenvalues because eigenvalue is dependent on the matrix. It does not depend on the eigenvalue. For example, if you are having A matrix, if I will write here 2, 1, 0 and minus 2. So here if you are look at A is because this is upper triangular matrix, so eigenvalue of A is what? 2 minus 2. And B matrix, if I will choose here 2 minus 2, and here if I will write here 4 and here 0. So this matrix also having same eigenvalue and same determinant, but we cannot claim that A and B also having same eigenvector. This is the first point. Second point is what about similar matrices? If suppose A and B, if you are having two matrices A and B, and A is also having same A and B having same eigenvalue, same determinant, same trace. So what you can say A and B are similar? This is also not true because this condition of similar matrices, if you are having two A and B are similar matrices, then this will imply trace same, determinant same, and eigenvalue same, but converse is not true. What is converse statement of this? Converse statement of this this is what? If A and B having same eigenvalue, same determinant, and same uh, characteristic equation, then we cannot claim that A and B are the similar matrices. But if A and B are similar matrices, then only we can say A and B having same eigenvalue, same characteristic equation, same determinant, and same trace. For example, suppose if you are having A matrix, if you are choosing example also we can take. If you are having A matrix equal to, we can write here 2, 1, and we can write here 0, 2. So you are looking eigenvalue of A is 2 and 2. And if B, if I will choose here identity matrix, here 2, 0, 0, 2. So here we can say that A and B are having same determinant 2 into 2, 4, 2 into 2, 4, same trace 4, 4, determinant also same, eigenvalue also same, but when you will verify A and B are not similar matrices. We can verify easily A and B are not similar. Why? Because if converse is not true, converse of the given statement is not true. If A and B are similar, then only this is true. But if you are having two matrices, same eigenvalue, same trace, same characteristic equation, it doesn't mean that A and B are similar. Now, how you will calculate that P matrix? For example, if I am having A equal to, if I am having A equal to 1, 2, 1 and 1, 2, and B matrix, if suppose I am having minus 1, minus 8 and 1 and 5. So suppose if we are asked to calculate P matrix, non-singular matrix P such that this P can be written, this P can be written as a P inverse of A and P. So how to calculate this P matrix? If you are having A and B, there are two matrices. You have to check A and B are the similar or not similar. Then we have to find P matrix, this P non-singular matrix. Why P is non-singular? Because if you are choosing P singular, then how this P inverse will does not exist. So because of that, this P we have to choose non-singular matrix. So how you will find this P matrix? So how to find this P matrix? So we can assume that P matrix is what? So first, if we are having this statement, this relation B equal to P inverse of AP. So we can apply here P both sides. So what will be PB? If I will multiply this from the left hand side, so PB will be what? You can take here P and P inverse is identity. So this we will get what? AP. So this also we can write condition of similar matrices. So now let us assume that let P matrix, because we have to calculate P matrix. So P matrix we can calculate A, B, C, D. So P into B will be what? A, B, C, and D. This is P matrix. And what is B matrix? B matrix is given to us -1, -8, 1, and 5. This equal to A into P. What is A matrix? 2, 1, and 1, 2. What is P matrix? We have chosen A, B, C, D. So now we can multiply both sides. So first component, what you will get? -A plus B, and second what you can get? -8A plus 5B minus C plus D, and second -8C plus 5D. This we can write next, multiply 2A plus C, and then next we can write 2A plus C, 2B plus D, and here A plus 2C, and then B plus 2D. So now we can equate both sides. We can equate. So first equation we can get, because -A plus B equal to 2A plus C. So we can write 3A equal to we can write B minus C. And second equation we can write -8A plus 5B. So we can write 8A equal to 8A plus D equal to 5 minus 2B. So this is equal to 3B. And next you can write 3C equal to A plus D. And fourth equation we can write uh, 3D equal to 8C plus B. So we are having four unknown A, B, C, D, and four equations. So we can solve, and easily we can calculate A, B, C, D. So after solving, we can get A value 1, B value 3, C value 0, and D value 1. So we can verify whether these four values are satisfying or not satisfying the given condition. You can check 3 into A. So 3 into 1, this equal to B. B is given 3. So 3 and C is 0, satisfying. Similarly, you can check second, 3D equal to 8C plus B. B value is what? D is 1. So 3 into 1, 3. C is 0. So you will get 3. So we can verify. So what will be P matrix? P matrix we can write 1, 3 and 0, 1. So like that, we can find P matrix by applying simple calculation. So this is so in this video, I have discussed about how to check 1, 1 and 2 of a linear transformation and what are the similar matrices. Thanks for watching.